What are the main effects of water mist fire protection? Water mist provides a high degree of cooling from water being evaporated, and the steam hereof provides an inactive gas which helps smothering the fire. In general, fire suppression or extinguishment by water mist application involves at least the following mechanisms. 1. Reduction of heat feedback to the fuel surface by cooling the fire gases. 2. Reduction of oxygen concentration adjacent to the fuel surface by air displacement, air dilution and oxygen depletion. 3. Attenuation of radiant heat flux to the fuel surface by water mist and water vapor. 4. Dilution of fuel vapor by fire products, vaporized water and air entrainment. And 5. Flame stretching and blow-off by gas current induced by water mist sprays. Where are the differences between water spray, sprinkler, and water mist systems? Water spray and sprinkler systems fight fires and protect the surroundings, primarily by wetting the surfaces of the fuel in the surrounding structures, to cool the structures and the fuel surfaces, and thereby suppressing or controlling the fires. Therefore, water spray and sprinkler systems have an increasing efficiency with higher water densities and larger water drops. Water mist systems fight fires and protect the surroundings primarily by evaporation of water in and around the fire plume. The evaporation of water takes large quantities of energy which cools the flames and reduces the net heat output of the fires, and the steam created helps smother the fires. Therefore, for fires in open space, water mist systems perform best when delivering water droplets in sizes which are large enough to penetrate into the fire plume and small enough to evaporate inside the fire plume. For fires in enclosures in particular, a higher temperature in the enclosure increases the fire protection effectiveness of a total flooding water mist system by enhancing mist vaporization. As a result, the effectiveness will eventually level off and will not increase indefinitely as the total water mist discharge rate is increased. The effectiveness is also very dependent on the size of the fire relative to the size of the enclosure. Not only because larger the fires generate more heat and correspondingly higher temperatures, but also because larger fires reduce the oxygen level inside the enclosure faster. The design engineers therefore should have a high understanding in the required characteristics for a water mist system to be effective, as well as the fire hazards to be protected. What are the advantages or disadvantages of water mist compared to gas systems? The advantages of water mist compared to gas systems are: 1. Water mist is non-toxic. 2. Water mist provides cooling. 3. Pump-equipped water mist systems are able to provide continued firefighting and multiple system activations. 4. Water mist systems are less sensitive to ventilation in openings. As a result, water mist systems are more suitable for installation in open rooms than gas systems, and could be configured in zones like sprinkler/spray systems. 5. Water mist systems may in many cases be activated before gas systems normally are activated, causing less damages due to fire. The disadvantages of water mist compared to gas systems are: 1. Water mist systems are most efficient when the fire is directly exposed to water mist sprays. 2. Water mist systems have larger and more complex piping configurations. 3. Water mist systems may cause water damage. And 4. Since heat is required to vaporize water mist, small fires in enclosures may not be extinguished. 5. Water mist systems may take longer time to extinguish the fire. What are the differences between low and high pressure water mist systems? High pressure and low pressure systems are tested and approved to the same standards, and systems being approved in accordance with the test standards do also in general have comparable firefighting capability within the type of occupancies which the approval standards cover. The difference between high/and low pressure water mist systems is primarily to be found in the nozzle designs, where different means of atomizing water require different water pressures. The different designs of water mist nozzles and the required water pressures set different requirements to water/gas supply, pump, control, and piping for low pressure and high pressure systems. Comparisons of typical parameters between high and low pressure systems are given in the table below. The actual system parameters depend on system brands and designs. If the system uses both water mist and gas at the same time, should it be installed according to gas guidelines or water mist guidelines? Water mist systems should always be installed in accordance with the guidelines with which the systems have been tested. The question is rather, should water mist systems which use water mist and gas at the same time be tested in accordance with the gas test standards, or in accordance with the water mist standards, or in accordance with both? To that question, systems being marketed as water mist systems should be tested to the standards applicable for water mist systems. Systems marketed as gas systems should be tested to standards applicable for gas systems, and systems being marketed as hybrid systems should be tested to some appropriate standards for the intended applications. Where can water mist systems be tested? Water mist systems usually undergo two kinds of approval tests: firefighting performance tests and component reliability tests. Both kinds of tests are conducted by accredited laboratories such as FM Approvals, FM, Underwriters Laboratories, UL, SP Technical Research Institute of Sweden, SINTEF, VDT, Danish Fire Laboratories, DFL, Danish Fire Institute, DBI, just to mention a few. Laboratories accredited only for component tests are FM Approvals, Underwriters Laboratories, VDS, DNV and others. Oh, thanks for the lecture. You are welcome. If you have more questions, you are always welcome to come to me, and I will try to answer you again.